Hello, everyone. I'm Ali Mohammadi. I'm going to present our recent paper at EMNLP 2025. Our title is Do LLMs Adhere to Label Definitions? So this is a joint work with my collaborators, Hanuma, Hemank, Edward, Dr. PK, and my PhD advisor, Dr. Frank Ferraro and Dr. Gaur. So we will talk about when we provide label definition in the prompt, how LLMs are receptive to these definitions. So we will talk about why LLM need to be a study for under these definitions. We will talk about knowledge conflict. We will talk about the connection between knowledge conflict and receptivity. We would have some definition integration scenarios. We would have key findings and the future work. So why large language models need to be examined with definitions? So we know that LLMs are trained on a lot of data. If we consider label definition, they may know the definitions for the label, for example, in a classification task. And we also, I mean, user may also include definitions in their prompt as external knowledge. So we want to see if these happen, if the internal and external label definitions are different, what would happen when we try such a experiment. So for knowledge conflict, we have two experiment, permutation, which is swapping the label definitions, and second is definition quality. So for permutation, if this is aligned permutation, when we have the corresponding definition for each label, and we can see it end up with correct prediction and correct explanation. When we swap the definitions for entailment and neutral, we can see that prediction is also shifted from neutral to entailment. And if we try swapping entailment and contradiction, we can see it end up with correct prediction, neutral, and correct explanation. So considering that experiment, we are going to try it on GPT-4, Llama 3, V3, and Mistral, which are which has different size, and we will use ESNLI, which is a natural language inference dataset. We have MCC as a metric. We have MCC underline A and M, which are for aligned definition with human definitions, and M for misaligned definitions. And we can see that when we have aligned definition, the performance is higher. For hate explain, which is another data set under the same experiment, we can see that with align, it has higher or at the same level performance. For well explain, we have higher MCC for align. For wise, also the trend is the same. For the second experiment, which is definition quality, first we have correct definition. Second, we have a slightly incorrect definition. So the changes is slightly. And we can see that prediction is correct here for correct definition, but incorrect for a slightly incorrect definition. But interestingly, when we have completely incorrect definition, which is kind of conflict between these knowledge and the internal knowledge, so it ends up with correct. And one reason behind that could be that when we have this conflict, the model just rely on its own knowledge and it end up with correct prediction. So we have these experiments for ESNLI. We can see that we have MCC for incorrect, a slightly incorrect and correct definition. And we can see that when we have correct definition, it usually have higher performance or at the same level, but except for Mistral, which is not expected. But interestingly, for GPT-4, when we have completely incorrect definition, it refused to respond because of the conflict. And it was interesting. For well explained, we have the same trend. When we have correct definition, the performance is better or at the same level. The same trend for hate explain and wise dataset. So what is the connection between these knowledge conflict and receptivity? When there is a knowledge conflict, there are two options. Maybe the model tries on when the model follows the external definition, it shows receptivity. And if the model ignores the external knowledge and it sticks to in its own knowledge, it shows low receptivity, relying on the parametric memory that it learns previously. So the last experiment, which is definition integration scenarios, first, we don't have any definition. We have a fixed definition comes from expert. We have adjusted definition using LLM. We have fixed definition plus few shot, the same as this, but with more few with few shots. So here, the first one, no definition involved. Second one, we use the input and include definition. We use the input, found some similar samples, and use them to adjust the definition and then make the prediction. And this is the result for GPT-4. So we can see when for ESNLI, the performance is higher when we don't have definition, but Rouge, which is for explanation, we have higher Rouge for definition. But for domain-specific data set, we can see when we have definition either fixed or adjusted, we have higher performance. So our key findings, LLMs rely on definition, but not always. For domain-specific tasks, it benefits more from explicit definitions than general tasks like ESNLI. For adjusted definition, it's often better than fixed definition. And when we have, there is a strong performance versus explanation gap here. Explanation improve with better definition, but classification accuracy doesn't always suit that. So our future work extend to broader task types like question answering, using mechanistic interpretability to see the inside the model when we have definition and when we don't include definition. And finally, assess real world deployment implications. Thanks for our collaborator and also a funding agency, DARPA, UNBC, and USISTEF for their support. And thank you for your listening. And please feel free to email us if you need, if you have any question, or you can see also the paper that is available online on the internet. Thank you very much.